All right, this video is going to cover the chip model versus the number line model for multiplication of integers. So let's start again with something that everybody should know how to do, 2 times 3. Now, when you're doing the chip model, these two numbers actually have two different functions in terms of how to interpret what the problem is telling you to do. So this is actually telling us to join two groups of 3 white chips. Now, the reason I got this particular interpretation from the problem is that the first factor, being positive, tells us that we're going to do a join. And the to part of it tells us that we're going to have joining two groups. Now, what are the groups consisting of? That comes from the second factor. Since this second factor is positive, that tells us that the chips are white and there's going to be 3 of them. So this says to join two groups of 3 white chips. So here's one group of 3 white chips, and here's another group of 3 white chips. If you really wanted to emphasize this, you could even circle the chips if you wanted to. That's not necessary, but if you go back to what we did in 118 with set theory, that might be a little more familiar to you from the way we kind of sometimes dealt with sets in that course. So obviously we got 6 white chips. Our answer is 6. All right, so if we do that with a number line, just like the two numbers had two different roles over here in the chip model, they're also going to have two different roles for our number line model. So I'll write this down here. I'll make a nice number line. Putting our labels on, which is something that's important. Okay, now in this case, this is telling me to join, or walk forward, I'm sorry, we're now in the number line model. So we're going to walk forward. Walking forward is what we do in the chip model when we join. 2 steps of length 3 units. And then the sign on this second factor tells us which way to face. So since the 3 is positive, we will face right. So 2 steps of length 3 units facing right. All right, so this looks like this. Here's 1 step of 3 units facing right. Here's another step of 3 facing right. We end up out here at 6. This actually represents a positive 3. This represents a positive 3. So if you think about the idea of multiplication as repeated addition, here we're adding 3 to itself twice. Okay, that is different than 3 times 2. We still get 6 for an answer, but you'll notice that the model is different. So this would tell us to join 3 groups of 2 white chips. So now our model might look like this. Here's a group of 2. Here's a group of 2. Here's a group of 2. So we have 6 altogether, and we get a positive 6. If we do that on our number line, now we're saying to walk forward 3 steps of length 2 facing right. So again, end up at the same place, but get there slightly differently. And that's what the commutative property tells us, is that these two problems, even though they represent different things, will give us the same answer. So that's important to recognize that commutative property is more than just switching the order of things around. It has to do with the physical reality of the situations that you're trying to represent mathematically. All right, so those are our 2 simple ones, and that kind of tells us what we're trying to do with the model. So now if we wanted to do 2 times negative 3, this is telling us to join 2 groups of 3 red chips. So I'll just write that here, join 2 groups of 3 red chips. So here's a group of 3 red chips, and here's a group of 3 red chips. This time I'm just going to separate them with a little space. You don't really have to draw the circles around them if you just kind of space them. So, but it's obvious now I've got 2 groups of 3. If I do this with my number line model now, and again with some foreknowledge that I have about how this is going to turn out, I'm going to draw this section of the number line for my representation. All right, so this is saying that I want to walk forward 2 steps of length 3 units, but this time I'm facing left when I take those steps. So I'm going like this and I'm going like this, and I get to -6. So this would be walk forward 2 steps of length 3 units facing left. Okay, so those are pretty straightforward. When the first factor is positive, it means you're joining groups of chips or you're walking forward the steps that you're taking. Now let's see what happens when that first factor is negative. Now let's say that we want to do the problem -2 times 3. All right. Now, remember with the chip model, we are either joining chips or we're taking chips away. And so in this case, with the first factor being negative, this means we want to take away 2 groups of 3. And again, that second factor tells us how many are in a group and what color they are. So 3 white chips. Okay, so how do I do that action? Well, I have a problem. I don't have any chips to take away. How do I get chips? Well, another way to represent nothing is those 0 pairs. So what I'm going to do is I'm going to supply enough of these 0 pairs that I can do the action that's required by the problem I'm trying to do. So the operation says I want to take away 2 groups of 3 white chips. Here's one group of white chips. I'll cross them off to indicate the takeaway. Here's another group of white chips. I'll take those 2 groups of 3 white chips off. I now have 6 red chips, so my answer is -6. How does that translate over here to a number line model? Well, take a minute here to draw a nice number line. And now what we're going to do is, instead of walking forward, we're going to walk backwards. So we're going to walk backward 2 steps of length 3. The second factor tells us the length of the step, length 3 units. But this time, since the 3 is positive, we're going to face right, but walk backwards. All right, 3 units facing right. So how would that look? Well, I'm going to put my arrow here facing to the right, but from that point I'm going to walk backward. And then I'm going to do another step walking backward, and I end up out here at -6. So recognizing that these are still representing a positive 3 because they're facing to the right, but since I'm doing this multiplication by -2, it means that I'm taking those steps in the backwards direction. All right, well, let's do the last case then. What about -2 times -3? How am I going to interpret that? This is telling me to take away 2 groups of 3, and because the second factor is negative, now the chips I'm going to take away are the red chips. Just like in the first case, it's telling me to take away chips I don't have, but I can always in this model supply extra chips that I may need to do the operation by adding 0 pairs to whatever is currently sitting out in my work area. So I'm going to put some 0 pairs out. Now currently I still have a 0, but now I'm going to actually do the takeaway operation. So now I'm going to take away 2 groups of 3 red chips. Here's one group of reds. Here's a group of reds. So I've taken those 2 groups of reds away. I've got 6 whites, and that's how we end up with a +6 for that one. If we do this with a number line model, so here's our number line all ready for us when we get ready to do the operation. But now the -2 is telling us to walk backward 2 steps of length 3 units facing left. So now, you always start your operations at 0. I'm going to be facing left and walking backwards. So facing left, walking backwards takes me out here to positive 6. So that then gives us the models that we would use to help our students develop the rules, that if you have numbers that have the same sign, positive times a positive, you get a positive. If you have a positive times a negative, you get a negative situation. If you have a negative times a positive, you have a negative situation. And then if you have a negative times a negative, you get a positive. So what that tells us is if the two factors have the same sign, we get a positive result. And if the two factors have opposite signs, then we get a negative result. And this is what we want our students to develop for us on their own. There are no models for division that are clear enough to use, I believe, in a classroom situation. So what we do is we connect multiplication and division together for these students so that they can understand that. And I'll do a short video about that next. So I'm going to stop this one so it doesn't get too long.